This video we will discuss another exercise with conditional plots. This time we will try to make a checkers pattern. This is a challenging exercise that combines several tricks you've learned so far. In previous exercises we have defined each square separately. However, this is not at all doable when you want to define so many squares. After all, MATLAB is here to make our lives easier. So to solve this problem, we have to find a common feature of all red and all blue squares. So let's focus at the intervals of the red and blue squares. We see that the blue squares are at 1, 3, 5, 7, and so on. The red squares are at 2, 4, 6, 8, etc. You can already guess the pattern here. It's about odd and about even numbers. So what is the main difference between an odd and an even number? Exactly, an even number you can divide by 2. So how are we going to distinguish odd and even numbers from each other? Well, in a previous exercise we have learned about the mod function that can determine whether a number is divisible by something. So let's calculate the modulus of the numbers in this figure. Do you notice something? The outputs are alternating zeros and ones. So the modulus of an even number and 2 is always smaller than 1, and the modulus of an odd number and 2 is always larger than 1. So now we have a criterion for both the blue and red squares. Let's draw a logic flow to see when we should use which color. So in this case we have two input values, x and y. Let's first check whether x is odd or even. With this information we cannot do a lot since the color depends on both input x and input y. So therefore we also have to check whether y is even or odd. So let's check it in a figure. When x is even and y is even, we get a blue square as a result. When x is even and y is odd, we get a red square as a result. When x is odd and y is even, we also get a red square as a result. And when x is odd and y is odd, we again get a blue square as a result. From this we can derive that when both x and y are even or both x and y are odd, we get a blue square. But when either x is even and y is odd or the other way around, we get a red square. So let's open a new editor window to write our function. Our function should have one output and two inputs. These inputs are x and y. Always close the function with an end. Now let's go to the core of the function. In our logical flow, we have seen that if one of the two inputs, so x or y, is even, then the output number will be 5, a red square. So let's define the case where either x or y is even, so their modulus is smaller than 1. So we write if the modulus of x is smaller than 1 or the modulus of y is smaller than 1. And if that is the case, we want an output of 5, which corresponds to a red square. All other cases, so all the blue squares, are defined by the else statement. Now close everything with an end, and we can try to plot the outcome of our function. We use the conditional plotter again and refer to our function with at and then the function name. When we run it, we see that we do not get the outcome we expect. This is because of the OR statement. The OR statement should say x or y. However, MATLAB considers the OR statement also true when both values are true, so when x and y are true. In our logic flow, we have seen that we should only get red if one of the two is true, so really x or y and not x and y. Therefore, we should find another operator. Let's look in the help function of MATLAB whether we can find one. So for this, let's go to home and then the help function. Click MATLAB, language fundamentals, where all the operators are. Click operators. And now we're doing true, false, or Boolean conditions. So let's look there. And then we already find the list. And we already see that the fifth one is an exclusive OR. That sounds like we could use it. So let's click it. And we see that the XOR performs an exclusive OR operation on the corresponding elements of arrays A and B, but not both. That is exactly what we need. So let's use that one. Now let's replace the OR operator which we first used by the XOR. And now it should really mean that or X or Y is even and not both. Let's try to run this. And indeed, we get the checkers pattern we were hoping for. So now we know how to write functions with 2 outputs and 1 input, plot the output, and also find the MATLAB function that you need.